All right, so my name is Jesse, and I am the lead on the Conservation Stories Canada project, where over 2021, I'll be heading across the country, coast to coast to coast, to feature stories of conservation in action. In the meantime, amidst this pandemic, it's a series of large-scale virtual interviews, and I'm thrilled today to be joined by Dr. Jennifer Provencher. She is one of the leading all-stars of science in the entire country. Basically, whenever I talk to other conservationists, they're like, "Do you know Jennifer?" Which is a really good sign. So I'm always excited to chat with her, and thank you so much for sitting down with me today. I really appreciate it.
Awesome. I'm super excited to be here and to chat with you today.
Fantastic. So you are the head of the Wildlife Health Unit at the Canadian Wildlife Service, which is part of Environment and Climate Change Canada. What on earth does that entail? Like, what does that job look like on a day-by-day basis? Probably a lot of different things.
Sure. I've actually changed jobs recently. I'm still with Environment and Climate Change Canada, but I'm now a research scientist, which funnily enough, my day doesn't actually look very different. It's very similar. And so really one of the things that we think a lot about in my research group is the health of animals, the health of wildlife. And it mostly means migratory birds, but it also means a lot more species at risk. But it basically means we think about health and how we think about health in a lot of different ways. And so most people think specifically now, especially in the world of COVID, which we know actually is a zoonosis, right? A disease or a virus that has transformed itself from wildlife and entered into the human stream. And we do think about disease a lot, but we also think about things like plastic pollution and contaminants, and more we're actually thinking about, like, how do you measure health? Like, how do you know when a bird or a bison or a caribou is not kind of like feeling 100%? And so we think about those a lot in my group. So on any given week, we talk about climate change, we talk about mercury, we talk about plastic pollution, avian influenza, COVID-19, coronaviruses. And currently, we're actually talking a lot more now about plastic contaminants. So what are those specific contaminants that are coming from plastic pollution?
Yeah. So, I mean, it really does run the gamut. And I mean, it sounds like every day is a little bit different, which is pretty exciting. We could do a much longer interview than we have time for today, but we'll stick with plastics and see, what is it doing to wildlife? You mentioned contaminants coming off plastics. So this is animals eating plastics and getting poisoned by what's within it?
Yeah, it's a real mix, and we learn a little bit every day. So there are big pieces of plastic, what we call macro or megaplastic, and those animals can actually get entangled in it. And so you can imagine, remember back when we were talking a lot about the right whales in the Atlantic and they were getting entangled in fishing gear? That's a plastic pollution problem. But more what I do is look at the tiny pieces of plastic. And I actually have some here that we've pulled from birds. And you can imagine there's all kinds of little tiny pieces of plastic. And these plastics are in their stomach. And so some of them can actually cause lesions. And so you can imagine they rub around the stomach, and the stomach is a foreign object, right? And so the stomach has to kind of protect itself. And we found pieces of metal kind of like encapsulated in the stomach in some of the birds that we've looked in. And so there's this kind of physical effect of plastics. And certainly if they eat a lot of plastics, they can feel really full. So you can imagine if you were eating plastics, but not digesting plastics, you just kind of have that post-holiday dinner feeling in your stomach all the time. It doesn't go away, right? And so you don't get hungry. So there's that physical effect. But more and more what we're thinking about is, what are the chemicals that are kind of coming off plastic? So you eat a piece of plastic. Well, if you eat a piece of food, right, it digests, there's chemical breakdown, and those are nutrients that, absorb into your body and make you healthy. With plastics, you're not breaking them down, but your stomach acid's still doing stuff. It's still kind of dissolving the chemicals that are part of the plastic. There might be there might be chemicals part of the plastic. There's other chemicals that are kind of leached on or absorbed onto the plastic. All of that can come off in the stomach as well. And so what we're looking at is, what are those chemicals? Does it matter? What are the ones that we should be paying attention to? And then one of the stuff that we're doing right now, what I'm really excited about, is actually looking to see if it's being transferred to the eggs. And so we know from lots of work in the past that it doesn't actually take a lot of chemicals to really kind of mess up the development, right? We're really susceptible, we're really vulnerable to chemicals during those developmental stages. And so we're looking at whether those chemicals can be transferred to eggs. And one of the projects that we're doing right now, and thankfully is still going ahead in the lab even under COVID, is at the National Wildlife Research Center where I work. We actually have a specimen bank, and the specimen bank, you can imagine it's, it looks like a pretty normal 4-story building from the outside, but the basement of it, about half of it, are these huge room-sized freezers that are at -40. And so we have 3 of them. You kind of go to this antechamber. Even if it's in the middle of August, you're going to have to put your hoodie on. You've got to put, your jacket on. You have special boots, gloves. You have to go in, and you walk in, and it's shelves and shelves and rows and rows and boxes and boxes and boxes of tissue samples that have been collected over decades. And in this bank, we actually have egg samples from Arctic seabirds that go back to 1975. And so we've been able to pull egg samples from the 70s and the 80s and the 90s and the 2000s. And we're actually going to start to look for these plastic chemicals back in time in the eggs to see if they're showing up and if we can actually detect a change over time.
Yeah. Well, that's very cool. You're the first person to talk about one of these like super secret science buildings that are just like normal on the facade, but then inside there's like the mysteries of the universe. I love that. That's very cool. So, I mean, this is, it's kind of alarming to think about the fact that we're putting so much plastic into the environment that birds are eating this en masse, and not only are getting them, caught in it, but when they're eating it, it can be poisoning them. It can be like, cutting them open. I mean, this is not a happy story. And I know that a lot of your work is focused on conservation around the globe. So how do you your work has taken you around the world to talk to a huge variety of audiences about these issues and try and, lead to concrete action. How do you take that from the research that you're doing, where you're showing what's happening over decades in a negative way, and take that into something where people actually do something about it and make a difference? I mean, I guess that's the essential question of conservation, but what's your approach?
Yeah, I mean, one of the things about plastic pollution is that it's really tangible. People can see it, right? Everyone, you and I are sitting on plastics right now. We all can interact with plastics. And I also work on climate change, and as you know, and many people know, it's really hard to talk about what the effects are immediately, and you can make changes in your life, but you don't necessarily see an outcome. And so that's really hard. Whereas plastic pollution, it's actually really easy for people to see that outcome. And so we talk a lot about, especially with school kids, and I have my own child, we talk about litterless lunches, we talk about recycling programs, we talk about choices you can make in the store in terms of something that's wrapped in plastics, 6 different times versus no times, or, maybe only has 1 wrapping. And people actually can see the difference. And so you can reduce your own plastic footprint and look at your household level, which is really exciting, for everyone to do. And then you also can see it in the environment, right? So, we can see the litter on the streets. We can see, when you pick something up and put it, in the garbage or where it's supposed to be, we can see the difference. And so that's actually one of the things that's really exciting about plastics, is that the solutions are actually really achievable. Kind of like climate change, it's really achievable by everyone, but unlike climate change, it's this immediate output or this immediate outcome that people can see. Yeah. And so we talk a lot about what the effects are on birds and from remote places and highly urbanized places. We have a project actually looking at how gulls that are collected for other reasons, how they have actually finding, we think that they might have more personal protective gear or PPE in them kind of since COVID. And it's this idea of like, we see these changes in the environment, and the birds are actually helping us to track that over time. And so I think probably everyone has seen masks and gloves on the ground as we kind of move around, and they're not being disposed of properly. And so we each can have those actions, and you actually can immediately see it. And I think that's actually one of the most exciting pieces. And so the work that we're doing on plastic pollution has this kind of really immediate effect, talking to people, reducing their plastic pollution, and then also for them to advocate for those different practices, right? The fact that they can't recycle everything that says recyclable on it is really something that they can kind of do locally. And then also this chemical step that we're doing, because it's all of these chemicals are really, we're learning more about, they're being considered by, national regulations. We also have a new chemical that's a plastic additive that's, being considered the Stockholm Convention. And so it's this really exciting time that you can kind of work at these international levels and inform it, but also it's really, everyone that we talk to actually has immediate actions.
That is fantastic. I love that you can, the tangible results element of this really differentiates it from climate change, where you can see it readily. And what I love about plastic pollution personally is that it's an apolitical issue. No one looks at a beach covered in plastic and goes, yes, that's great, right? Everyone thinks that that's a bad thing. It's bad for tourism. It's bad for wildlife. It's bad for all sorts of things. So I'm glad we can connect the dots between something that, your average individual person can do and governments get behind it, as well. It's very exciting. I mean, it's a bad story, but there's a positive and a hopeful trend, which is fantastic. So, Jennifer, your work seems to always take you back to the Arctic. I don't know whether this is just by fluke or whether you absolutely love it, but if you love it, like what's the draw? Why consistently go back up to the north?
Yeah, for me, the Arctic, I feel like, is where I was really allowed to grow and understand a lot about science. And so one of the things that we don't talk about science, and often we don't often talk about it in science, we don't often talk about it in conservation, though it's a little bit more present, is really the idea about the way that I actually can do science is through relationships. And so because I did my master's work and my PhD work and my postdoc work, all with Arctic communities, in collaboration with community partners, in collaboration with Northern researchers, those are where my relationships are. And so I can think of a million really exciting questions that could be answered anywhere, but really the relationships with people using wildlife, with wildlife, caring about wildlife, culturally important wildlife, those are all in the Arctic. And so as funny as it might sound, the easiest place for me to carry out these research questions is with the partners I have relationships with, and they're almost all in the Arctic. I could start programs in Southern Canada. In theory, I could start programs in the tropics. And I often joke about that on these warm, cold winter days. Don't seabirds exist somewhere warmer? But the reality is that the Arctic is a wonderful place to work. The people there are amazing. The relationships we have, I've been working with some of our partners now for over a decade. The communities that I work with are fabulous, and it's an exciting place where co-management of wildlife species and co-management of protected areas with the indigenous peoples of the Arctic, the Inuit, is happening in real time. And so it's really exciting place that I can carry out these questions.
I love that. I mean, you're the first person to highlight that scientists are people too. I mean, this is something where that relationship is so important. And I guess one day maybe if you start slowly but surely building up relationships in like the Caribbean, you can have an alternate research project there. But it's really heartening to see that there's so much great work happening in the north. Sort of just one last question, and something that a lot of the people that have come on this program have talked about is this sort of indigenous collaboration between Western science and indigenous communities. So what does that actually look like on the ground? Is this something where it's been a slow process to build up that, a multi-decade thing where they're now sort of spearheading these conservation efforts or collecting the data themselves, or what does that actually entail?
Yeah, that's a big question that we could have a whole other conversation about. But I think the most important thing is that it looks different for everyone. And so a lot of what we do in my group and we think a lot about is how do we, respectfully weave indigenous-based knowledge, indigenous science with Western-based science or Western-based knowledge. And that can look a lot of different ways. And I actually think about a lot of my programs, and I challenge my students to think about a lot of it is we think about it in a weave, but it can be a tight weave, it can be a loose weave, it can be a very heterogeneous weave where sometimes the indigenous science is more present, sometimes the Western-based science is more present. Sometimes it's a really loose weave, and I often think about this as it's actually with the communities that we have really close working relationships with. I often think about it as the elders and the hunters and the co-management committee. They give me homework. I go away and think about it. We do some work together. I bring it back. They tell me yes or no, or ooh, not so good. Oh yeah, follow that up. And then I go away and think about it. So it's this give and go relationship. It's a loose weave, right? It's not, they're not present in every single discussion, not because they don't want to be, but because they've given me homework and they have other priorities that they need to do more attention on. Yeah. Whereas we have other programs, there's one particular in northern Newfoundland and Labrador in the territory of Nunatsiavut. With the Nunatsiavut government, we have several very tight weave projects. And so they were co-produced, co-led, co-sampled, co-implemented, co-analyzed, and it's a tight weave. And so that program is suited to what they are asking us to partner with them on. And so it can look really different. And I think that's one of the things I'm really trying to stress whenever we're talking about these, is that this weaving of Indigenous science and Western science has to look different for every community, has to look different for projects depending on what the needs and the capacities are, and really is going to be heterogeneous across the country. There's not this one size fits all. But I think that's the really exciting part as we explore these relationships and partnerships together, is we just have to have conversations about what works best for the situation, and frankly, what partners and Indigenous communities and Indigenous scholars and academics really need for us to support different questions that they're interested in exploring.
Yeah, that was an absolutely beautiful answer, the most thorough of anyone I've had on the broadcast, so I really, really appreciate that. Dr. Provencher, I know you've got to go to other meetings and go save the world, so I'm going to let you go, but thank you so much for